The next page of that worksheet has another g prime sketched for us, and it's up to us to figure out the original function g. So this is the Fresnel integral curve. This is its derivative, and we want to figure out what the original function looks like. So again, we're going to indicate which intervals g, the original function g, is increasing or decreasing, where the original function g is concave up or concave down, and then sketch the original function g. So here it might actually be easiest to start from the center and work out. So if you didn't see this, it's in the second page of that Excel file. So go ahead and do that now if you haven't done it already. So what can we say? G is increasing where g prime is positive. So that's from here over to here. G prime positive, g increasing. And then from here to there, there's not much room, so I'll just write decreasing and then increasing. And then it's getting harder to eyeball from there to there, decreasing from there to there, increasing. And that wavelength is getting shorter and shorter. And then over here, g prime is negative. So g is decreasing, and here to there, g is increasing, decreasing, increasing, decreasing, increasing, etc. And then where is the original g concave up or concave down? Starting at the middle here, g prime is decreasing all the way out to here. G prime decreasing means g is concave down. So from here all the way out to there, g prime decreasing, so g is concave down, and then like that, concave up, out to there, concave down, etc. And over here, all the way up to there, g prime is increasing, g is concave up. So from here to there, g prime is decreasing, so g is concave down. From here to there, it's kind of weird, I'm moving my pen backwards here. I'm noting intervals going backwards, but I always have to think, going from here to here, g prime is increasing. So g is concave up. Going from here to there, g prime is decreasing, so g is concave down, etc. All right, and then sketch the original function supposing that g of 0 is 0. So we're starting here. And originally the derivative is 1, so we're just increasing at a rate of 1. So we're just doing that. And then we know it's going to be increasing but concave down, so it's going to have a little bit of a curve like that to it. Pretend that was more linear. By the time I get to here, then g is going to be decreasing and concave down. And it's hard to know how far down to draw it. Let's just try that. And then g will now be concave up, but still decreasing until we get to that spot there, something like that. And then g will be increasing concave up until we get to 2. And then g will be increasing concave down, but it's got less and less time to be increasing or decreasing, so we aren't going up as far. That's maybe too subtle of a point at this point in our class, but it's kind of nice to think about. And then once we get to there, g will be increasing. I've got to eyeball this. G will be decreasing concave down till we get to there, and it'll probably just kind of keep switching, almost like a sine wave, but with the amplitude getting smaller and smaller. Then we'll think about that all going backwards. here the derivative is still 1, so I still need to draw something like y equals x. And in this range we are increasing and concave up, but I'm moving my pen backwards, so maybe I should move my pen forwards. And then over here we're decreasing concave up, so something like that. And then probably something like that, not being very careful there. So that is ideally the function that gives us, so this is g, and this red curve is g prime. So let's check it against the actual graph and see how we did. All right, here's the more exact graph in Excel, and I think our drawing was pretty good. Now, I said this is used in planning like transitions in train tracks and roller coasters and roads and stuff. I'm not saying that train tracks actually do this on a regular basis. Roller coasters might, but it's not saying that this curve exactly is what train tracks and roads and roller coasters follow. It's just used in the planning of them.